let's talk very briefly about the modern generative AI that has hit the news in the last year. Now, things like ChatGPT, the generative AI models, they're just machine learning models. There's nothing fundamentally new going on. And in fact, the earlier version of GPT, GPT-2, before GPT 3.5, which was when OpenAI went live, is a model that we have in our network repository. It's got a particular architecture that's designed for string manipulation, so it's actually quite small. There's a couple of graph layers and a chain here that's got more chains inside it that have probably things inside them. So there's still some complexity there, but it is just a neural network that has been trained. In this case, this particular version has been trained on web text data, which is a corpus that's been scraped from the web. And what this particular model does is it's a predict model that will take an input string and predict the next string that you'll get. So if I give it the input string, Albert Einstein was its best prediction is that would be followed by the word teacher. So it's just a class predictor for what is the next best word. And that's all that ChatGPT fundamentally is. GPT-4 that is the kind of current state-of-the-art model is just doing this fundamentally at its core. Now, if we can predict the next word, of course, we can add that word to the end of that and say Albert Einstein was a teacher. Let's put it in there. Oops, I didn't want the quotation marks. And we can predict the next word that follows that now. Oops. I could actually type correctly in a live webinar. Albert Einstein was teacher who. So we can string that together recursively to now have it write code. So here I'm just doing that. I'm nesting, I'm applying recursively that, in this case, 10 times. And we get Albert Einstein was a respected German mathematician, finally because he was an early, and I could keep going. So we're now generating prose simply by making sequential word predictions. And that's all that ChatGPT is doing, is a model that does this at a very large scale. So where this thing has a few hundred, maybe 100 layers with a few hundred or 1,000 parameters, the large language models have hundreds of thousands of parameters. They're very large and trained on very large models. So this ability to predict text becomes extraordinarily good, so that it can predict the answer that would follow a question or the actions that would follow a set of instructions. And they start appearing to be human-like intelligence because it can start predicting the conclusion from that would follow some reasoning statements, and it starts looking like intelligence. But in the end, all it's doing is predicting the best words that follow. Now, unfortunately, these models are so big that they are, or at least the state-of-the-art ones, are beyond the ability to run on a typical desktop computer. There's the new generation of mid-sized language models that we're trying to curate to have in the whole kind of framework that allows them to be transformable and retrainable by our mechanism, but we're not quite there on that yet. But for the state-of-the-art ones, that you're not going to be able to run them on your home computer. So what we've done with the Wolfram Language is to integrate them in to the language as external services. So if I do this LLM synthesize command here, I can take an instruction here and call, in this case, the OpenAI API and get that the answer back from that remote service. So this wasn't executed locally on my computer like almost everything else was in this demonstration. This was executed in OpenAI's GPT 4, I think, is the default. No, 3.5, I think I've called here, model to generate a limerick. And that's not a very good limerick. I might give it another go, but you get the idea. Now, it turns out that from a using these models to their full power, not simply generating sort of conversational chat or text writing, there's a few paradigms that make them really quite usable within the language. And unfortunately, I've accidentally deleted this. I'm just going to recreate here what should be in the notebook, and it's probably missing from the downloadable notebook as well. We have a notion of being able to make a thing that looks like a function in the Wolfram language, but is powered by the machinery of large language models. And the idea is that you are basically programming in English rather than programming in code. So what my function is going to do is to classify something that we haven't seen into either animal, vegetable, or mineral. So this is what's called prompt engineering, where I'm kind of giving instructions in English, but this will be fed to the LLM before the parameter and sets up the task for it to do. I probably need to give it a bit more here by saying you have to be very pedantic with these things. Return only one word. And let's see what happens if I apply that function now to this list of data. And so I'll call that function 4 times for each of the 4 data points. And it's done cat, animal, vegetable, cabbage, vegetable, diamond, mineral. So it's done the right thing for all of those. And I've thrown in a curveball here of something that isn't obviously any. And it's decided animal is a better classification than vegetable, mineral for a concept like love. And the other basic paradigm that we have is the same kind of thing, but driven by examples, which it turns out large language models are really quite good at generalizing from. So here I'm giving it some prompt engineering again. I'm saying extract the name and age of a person from the text, return a Wolfram Language association with the keys name and age, looking like this. And then here's some examples. Here's an example. John is 52, and I want you to return this data structure. A man called Mike is old. I want you to return this data structure. That's given an example of what happens if the age isn't mentioned at all. I've said missing. And I want you to parse that as a Wolfram Language expression when we get it back. And hopefully if that works, I can now give it this unseen text. My manager, Jane, is very young. She's only 30. And it said name Jane, age 30. So it's correctly pulled out the parameters and restructured that data. And this is really powerful for sort of dealing with unstructured and data and transforming data, doing sort of classification tasks where you have limited amount of data. So where I might have, for something like this, used classify if I had thousands of examples, when I only have a concept and enough energy to generate, well, in this case, no examples, but I might generate a dozen or 2 dozen examples quickly, but I don't have a proper data set, then large language models are quite good at using their innate knowledge to extrapolate on the description or the examples to be able to do the right thing. And a couple of other paradigms within that world is the idea of providing tools. So this is bringing the best of the computational world together. Here I'm saying use OpenAI to write a paragraph about Chicago, New York, but I don't trust it to know up-to-date information about things like city populations. So I'm telling it there's a tool available, which is going to find the populations of cities, some prompt engineering to say what it does, the parameter it expects, and I'm going to run the Wolfram Language command. So this is part of our inbuilt data. I'll just show you what that does. If I type something like London city and then type nation, we're looking that up from a database within our system. What we're doing is giving the LLM access to that computational tool so that the LLM is going to happily go off and try and do this. But at some point, hopefully in a few seconds, we'll get our answer back. But with remote services, sometimes you're not in control of when they want to talk to you. It's having another conversation. So this has ended up being a multi-part conversation between my computer and the LLM. And I'm hopeful this time it will stop having a conversation backwards and forwards. Normally this takes a couple of seconds. So I think OpenAI is a bit busy at the moment. Now, what's it done here? So from here down to here was all ChatGPT. But at this point, it's realized it'll be useful to get some facts. It sort of painted itself in the corner here. The city of Chicago has a population of approximately, and then it's called back to my tool and run through Wolfram Language a lookup from the database of the population of Chicago, which is then written into the answer, and then it's carried on its way, and it's called back again. So this is why there was a conversation where the LLM was doing some work, we were doing some work, the LLM was doing some work, we were doing some work, and then the LLM wrote the conclusion, and we get our paragraph containing the best of both worlds. One other thing in this world is also in this generative world is image synthesis, but it's basically the same kind of idea. We're using big neural networks that have been trained on lots of things that combine text and, in this case, images, and we are giving it prompt engineering to describe an image that we want to synthesize, and it's got enough knowledge about the short and long-term relationships of images and things like dogs and where a cigar would go when you smoke it, and it's come up with this example. And these LLM and generative things, they have a certain amount of randomness in them because that makes them seem more human-like. So if I call this again, I'll get a different answer. I don't see any sheep in the background, but maybe that's a sheepdog in the background staring at my becrowned, cigared hound. So that covers what I want to talk about. We've gone from the basics of what these things are doing in simple cases, the fully automated commands in the Wolfram language like classify and predict, and how you work through the training process of train, measure, refine, and test, and what the neural network framework allows in the same kind of paradigms, but in a much richer lexicon of language.